All right, so if you're watching this video, you're probably in here because you need a little bit of extra help on one of two objectives. Either the objective about recognizing characteristics of metals, nonmetals, and metalloids, or you had a little bit of trouble with density, calculating density, identifying things based on their density, or maybe you had trouble with both of them. So I'm going to go over several things, and then at the end I'm going to go over the quiz that you took. And once you've done everything that I've asked you to do and studied, you'll be eligible to take the requiz. All right, we're going to start with this sheet right here. You got a half sheet of paper that you wrote the words in by hand. Okay, you have definitions. You should study this list of words and definitions. Density is the amount of matter in a given amount of space, or remember, density is mass divided by volume. Okay, mass, remember, is the amount of matter in a substance. Grams are your unit for mass. Cubic centimeters or milliliters are your units for volume. A metal, characteristics of a metal. They are malleable, meaning that they can be hammered into flat sheets. They are shiny. They are good conductors of heat and electricity. And metals are located on the left-hand side of the periodic table, basically to the left of the little stair step or zigzag line on the periodic table. Nonmetals are brittle, meaning if you hit them with a hammer, they would break. They're poor conductors of heat and electricity. They are not shiny, which means they have a dull luster. And they're usually located on the right-hand side of the zigzag line on the periodic table. Hydrogen happens to be an exception. Hydrogen is a nonmetal, and it's located all the way to the left. But you don't need to worry about why at this point. But anyway, most of your nonmetals are to the right-hand side of the zigzag line on the periodic table. Then we have metalloids, okay, sort of metals. Okay, metalloids have properties similar to both metals and nonmetals, so they have some properties of each. And metalloids are located along the little stair step or zigzag line on the periodic table. Okay, luster refers to the ability of an object to reflect light. So if you describe something as shiny or dull, you're talking about its luster. Conductivity is the ability of a substance to transmit heat or electricity. Okay, for instance, we use copper wire in our houses for wiring because copper conducts electricity well. And that should make sense because copper is a metal, so copper is a good conductor of heat and electricity. Malleable. A substance is malleable if it's able to be hammered into sheets. Okay. Ductile is not on here, but you might want to add it to the bottom. Ductile means that something is able to be drawn into a wire. Okay. Okay, so I can't remember exactly where I was. So malleable means that you can hammer something into sheets. Metals are malleable, for instance. Ductile, a substance can be drawn into a wire. Metals are ductile. Think of copper wire. Okay. Grams per cubic centimeter or grams per milliliter are the units for density. And then the term volume. Volume just refers to the amount of space an object takes up. So some of you guys missed some of these terms just simply because you didn't study the vocabulary, and you need to make sure that you do that. Okay, let's do a little thinking about density. First of all, we're going to write the density formula. Remember that density equals mass divided by volume. Number 2, calculate the density of a metal cube shown below. The mass is 8 grams and the volume is 4 milliliters. What is the density? Write the problem and answer below. All right, so the formula, density equals mass divided by volume. And then I put my numbers in. 8 grams, which is my mass, divided by 4 milliliters, which is my volume. 8 divided by 4 gives you 2 grams per milliliter. So the density of this block is 2 grams per milliliter. Now, imagine that the cube is split in half exactly. Okay? Well, think about, what is the mass of half the cube? Well, it's going to be half of the mass that you originally have, which is 4 grams. What is the volume of 1/2 of the cube? Well, it's half the volume that you originally had. Okay, so if I calculate the density of half the cube, then I'm taking half the mass and dividing it by half the volume. But half divided by half, 4 divided by 2, gives me the same density. It's still the same density, which should make sense because it's still the same substance. Okay? So on number 4, does size affect density? No. If I have a block of aluminum, it doesn't matter how big the block of aluminum is, it's going to have the same density because the specific density for aluminum is a property of aluminum. It's got a unique density. Okay? Now, I will say this. Remember the demonstration that I did with the piece of bread? For instance, if I had a little cube of bread, y'all know that I could take that bread and I could squish it. Squish, 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 and make it fit into a smaller volume. Now, if I did that, I still have the same amount of bread, but now I've forced it to occupy a smaller volume. So that does change the density. Okay? And it would make it more dense because I have forced the same amount of mass into a much smaller volume, so that increases the density. Okay, let's go on to our next sheet. All right, so let's look at this worksheet, okay? If I have blocks and each of the little dots represent a little unit of mass within each box, then let's look and do some thinking about the masses and the densities and things like that. So number 1, which object has the greatest mass? Well, that would be the one with the most little dots in it. Okay. Okay. Number 1, object E is going to have the greatest mass because it has the most dots, which represent, a little unit of mass apiece. Which object has the smallest mass? That's going to be object B because there are only 5 little dots, meaning there's only 5 little units of mass. Which has the largest volume? Well, that's the one with the biggest box. That's going to be object F. Which object has the smallest volume? Which one's the smallest box? In other words, that's going to be A because it takes up the least amount of space. Which 2 objects have the same volume? Well, that's going to be object B and object C. Why? Because the boxes are the same size. Which 2 objects have the same mass? That's C and F, because they have the same number of dots. Okay? But you're noticing, hopefully, that C and F are not, they have the same mass, but they don't have the same volume, and therefore they're not going to have the same density either. Okay? Okay, so I know you don't have the questions right in front of you, but I'm going to read them and we'll talk about it. If 2 objects have the same volume, do they have to have the same mass? Well, no. Look at B and C. They have the same volume, but they obviously do not have the same mass. There's a lot more mass crammed into block C than there is into block B. Okay, now number 8, which object has the greatest density? Okay, that would be object C. Why? Because the mass is crammed closest together. It's most compact. Those dots are forced close together. Okay, which one has the smallest density? You're going to look at which one has the dots spread out the most. That's going to be D because there's only 6 dots and it's a pretty big volume. Okay. Number 10, which 2 objects have the same density? That's going to be object A and object F. How do I know? Well, look at the dot spacing for A, look at the dot spacing for F. Okay, there's about the same amount of mass in each volume. Does that make sense? Okay. Which 2 objects would you expect to be made of the same material? I would say A and F because their densities are the same. Why does the object with the largest volume not have the largest mass also? Well, because the density of the object with the largest volume has a smaller density than the object with the greatest mass. Okay? All right, so hopefully that'll kind of get you an idea of density is not just about mass, it's not just about volume, it's a ratio of how much mass is packed into a certain volume. Okay? So C is the most dense because things are packed together the closest. E is probably next, okay, more dense than anything except for C. Pardon the bell. A and F have the same density because it's about the same level of compactness. And then there's B, and then D is the least dense. Okay? Okay, so here we are at the quiz, and we're just going to go through the questions real quickly. Number 1, mass of an object per unit volume is an object's density. That is answer choice B. Again, I would consult this piece of paper. The property of an object that can be hammered or pressed into flat sheets. Again, that is on this sheet. That's malleable, so malleability. Which of the following is not a physical property? We did a warm-up about physical versus chemical properties. Chemical properties can only be observed during chemical reactions. So answer choice C is not a physical property. Elements that are what? Are found mostly on the right-hand side of the periodic table. Okay, here's our periodic table. The right-hand side, these are our non-metals. Okay, your non-metals are on the right side of the periodic table. Elements that are metals tend to be ductile, meaning you can draw them into a wire, malleable, meaning that you can hammer them, and good conductors of heat and electricity. They also have high densities. Those are your metals. Number 5. Which of the following elements are found along the zigzag line of the periodic table? Okay, here's your periodic table. Those are your metalloids. Metalloids are color-coded white on my periodic table. Okay, they're not always white on every periodic table, but on that one there is. Okay, so let's flip. And number 7, which wood on the list is the least dense? Well, you're going to use this list. Down here, you've got woods. Balsa wood is just 0.12. It's very light wood, so that's going to be B. 8, water, kerosene, and metallic mercury, or liquid mercury, are all liquids at room temperature. If 3 were poured into a graduated cylinder, which substance would settle to the bottom? Well, water has a density of 1. Mercury has a density of 13.6, and kerosene has a density of 0.8. Okay, so I took it just a minute to write the densities. Mercury is most dense, and the most dense substance is going to settle to the bottom. So mercury would be on the bottom, water would be in the middle, kerosene would be on the top. Will a piece of oak float in kerosene? Well, oak has a density of 0.85. Kerosene has a density of 0.80. So if you put a piece of oak in liquid kerosene, the oak would sink because it's more dense than the kerosene. All right, if the same mass is squished into a much smaller volume, what happens to density? Think of the bread. Take the bread, squish it into a much smaller volume, and you've made it more dense. Okay, so the density A increases. An unknown metal has a mass of 345 grams and a volume of 50 cubic centimeters. Calculate the density. Okay, for number 11, 345 divided by 50 gives you 6.9. I wrote all of the numbers from the table I gave you. 6.9 matches up with C, zinc. Okay, piece of wood is found in Arthur's workshop, but he doesn't know what type of wood it is. Its mass is 100 grams and its volume is 250 cubic centimeters. 100 divided by 250 is going to be 0.4. Okay, so that's alder. A student picks up an unknown material. It has a mass of 262 grams and a volume of 100 cubic centimeters. 262 divided by 100 is going to be 2.62. These are all kind of in the ballpark. The only thing that is way off is D, cork, so it can't be cork. Okay, so that should get you through the basics for your tutorial for density and metals, nonmetals, and metalloids. So study real hard, and when you're ready to take the requiz, let me know. And make sure you get a parent signature on your quiz.